Greetings everybody. So what you see here is a problem from our assignment that claims to be a geometric series of some kind, and I'd like to show you how to work it. Okay, so I'm going to re-express it down here like this. I'm going to say, okay, I've got that series. That's the series you saw up there. It's asking me to figure out what this grand total is. I guess the difficulty with this one might be that it's not clear how many terms there are. These ellipses, these three dots, tell me they're leaving out the middle. Some kind of pattern is established, but it doesn't explicitly say what all these terms are, or for example, like which term this one is. Like, what's the last one there? Is it the 10th term, the 20th term, or what? Okay, so let's take it apart like this. So first I'd say, is this really geometric? How would I know? I see that it does tell me that, but can I prove that, or what can I demonstrate about that? Well, a geometric series is such that any term is this number r, called the common ratio, times the previous term. If you solve this equation for r, then that turns out to say that r can be found by any term divided by the term that came before it. Okay, so let's try that out. So if I wanted to figure out what r is, then I could, if I wanted to, take 1/10 the second term and divide it by 1/2 the first term. Okay, that turns out to be a fifth. Okay, so it's a geometric series where r is a fifth and a1, the first term, is 1/2. We could verify this if we want to. A half times a fifth is a tenth times a fifth is 1/50th, and I can verify from there that take any term times a fifth and you get the next term. Okay, so it's geometric. Now, I guess from here, if I want to calculate what 1/2 plus 1/10 plus 1/50th all the way to 1 over 31,250, I would just have to know how many terms there are. Here's the reason. There's a formula to calculate the partial sum of a geometric series. It says Sn equals a1, 1 minus r to the n power over 1 minus r. In that formula, n is how many terms you want to add up. A1 is the first term, and r is the common ratio. So if I know how many terms are here, then I can go straight to this formula. Okay, but just looking at it, it doesn't tell us. If these dots were filled in and I could see all the terms in the middle there, then I would know. Okay, so somehow we're gonna have to figure out how many terms there are. All right, so I'm not going to skip straight to step 3. I need to go through step 2 of figuring out how many terms there are. Okay, now you might think the way I'm doing step 2 here is too complicated, but I think you should know more stuff rather than less, generally speaking. Now, in spite of that, in spite of the fact that I'm going to show you how to solve for which term it is, I'll say this: you can take every term here times 1/5 and fill in all the middle ones until you get that, and then you'll know how many terms you have. Okay, so you could do it like that, but I don't know. What if that's 20 terms down? I might not want to do that, or 50 terms down, or who knows. So I'm going to go ahead and solve for it. All right, now I'd like to write some kind of formula that tells me what any term is, and I can take this and use this to my advantage. If I have a formula like that, a1 times r to the n from 0 to infinity, that will be the formula for a geometric series with the first term of a1 and a common ratio of r. If I can express it that way, then I'll have a formula to get each term, and then I can solve for whichever one gets me that last one, and then I'll know how many terms are there. Okay, so in my case, a1, first term is a half, r is a fifth. So there's your formula that'll recreate this series term by term. You could try it out. You can put 0 for n, you could put 1 for n, 2 for n. It will recreate this exactly. Okay, so if I'm going to solve for which term this last one is, then I could take that and set it equal to 1 over 31,250 and then solve this equation. Here's how you do that. So I'll multiply both sides by 2. I'll cancel the 2 and the 31,250. I'll distribute this power to the 1 and the 5. I'll invert the equation, and then this is an exponential equation which you solve by logarithms. This is the change of base formula for logarithms right there, and that turns out to be 6 exactly. Okay, so what's that tell us? That tells me how many terms are here in this series. It tells me which term that is. Okay, if n is equal to 6 gets you this term, that means there's 7 terms total, because 0 got you the first term. So 6 gets you the 7th term. All right, so it's going to look like that. Okay, now that's all I wanted to know. If you could figure out through trial and error that that was the 7th term, then fine, you can still figure it out that way. But I wanted to show you this because I think you should know that too. All right. Okay, so now we know that all we wanted to do from the beginning is find the partial sum of that series. This formula will do it. I know the first term of that series is a half. I know that r is a fifth. And now I know that it's the sum of the first 7 terms that I'm trying to calculate. So, all right, I have a half, 1 minus 1/5 to the 7th over 1 minus 1/5. And that turns out to be this number right here. And I just gave you the number that is the final answer. Now, I know that you can do that with a calculator. I don't know how much luck you'll have doing it with a calculator. It might depend on which calculator you have. But how about this? I mean, I do think you should know how to do things. It's fine to use a calculator. I think it's a little questionable to use a calculator and have no idea how to do things without one. So I'm going to show you the details. I'm trying to do this. A half, 1 minus 1 over 5 to the 7th power over 4/5. I'll do that this way. A half divided by 4/5 is a half times 5/4. That's 5/8. Then I'll subtract these fractions. That's 1 being 5 to the 7th power over 5 to the 7th power. So it's 5 to the 7th power minus 1 over 5 to the 7th power. From there, I'll cancel this 5. So think about it like this. I'm canceling this with that, and it's going to leave me 5 to the 6th power. Okay, so I get 5 to the 7th power minus 1 over 8 times 5 to the 6th power. Calculating that part directly, I'll get this, and then I can reduce this fraction and get that. Okay, so I show you that because I think it's good to know how to do some arithmetic, even if you do use a calculator. But who knows? What if you're just not getting it to work there? Okay, you try to plug that in, it's not coming out right. At least you can figure it out this way if you had to. Okay, so that's how it works. Now I'll give you some freedom in how you work this one. If you can go straight to step 3 because you can figure out there are 7 terms there, maybe by trial and error, maybe because you write out the terms one at a time until you got to that one, then you can do it that way. But at least consider how I solved it. I think somebody in Calculus 2 should know how to do it either way.